Hey everyone, in this video we are going to continue with the creation of the cube class. Since here we have finished creating the header file, and now we will go about creating the C++ file. Now that that's here, we're going to get started with the three constructors, but before that I need to include the myCube.h, and then we can continue now. So I'll say cube, and what's really nice about this is that now I can go from the parent classes and I can call the rectangle default constructor as well as the shape 3D default constructor, and all I need to do here is to say that surface area is equal to surface area, and do the same thing with volume. So the attribute volume will be equal to our method call of volume, and actually we'll be needing to copy those because as we continue to the parameterized default constructor, we're going to say double length. The same methodology is going to apply. So as we called the default constructors from for the unparameterized constructor, here we are going to do the same thing with the parameterized, right? So we're going to provide a length and a width, as well as call shape 3D with depth, right? And then now we will continue with updating surface area and volume. And actually, let me tab this out just one more so that way there's a little difference, right? We know that the body of code starts here, right? Because this has been a little bit tabbed out. Anyways, let us continue with the copy constructor. And well, the copy constructor is going to take a little bit of a different approach. Here we're just going to call the respective setters and getters for all three methods. Not methods, the attributes for all three attributes. I'll say get length, and that should be it for that. We'll do set width, c.getWidth. Right, we're calling the appropriate setters with the appropriate getters from cube. So the thing is that we got to make sure that we define these, especially for get depth and set depth, because since they were pure virtual functions from the shape 3D class, we definitely need to implement them here. So this will be all for our constructor, or three constructors, and let's move on for the three getters that we need to implement. First, starting with the get depth. So here we have get depth, right? And we need to implement this because it's an abstract class and my shape 2D. So because of that, it is mandatory that we implement the get depth. However, here when we do get surface area, right, we are doing this because this is a method that has been created within the cube class that's not inherited, right? Since get depth was inherited, we need to make sure that we implement it because it was inherited from an abstract class, right? So we are implementing these getters for different reasons. Get depth has to be implemented because it was inherited from an abstract class. So that means that we need to implement the details. However, surface area and volume need to be implemented because they are created within the cube class and they're not inherited from anywhere else. So let's take a quick break and take a look at shape 3D. So we finished the get depth, and now we need to implement our setters. So we have set depth, purely abstract virtual function similar to get depth. And in cube, here we are overriding the three setters, so that way we can update our surface area and volume attributes with the surface area and volume methods. So why don't we go about implementing those now? And we will begin with set length, const. And so what I'm going to do here is that I'm going to call shape2d's set length method, right? And then from there I'm going to do surface area and volume. Actually, I don't want to do shape2d. I should probably do rectangle. It's actually best to do rectangle because rectangle will call shape2d's set length method, and as a result it can call it from there. It's good to call rectangle and not shape2d because double length, don't need a const. It's good to call the rectangle set length because one thing that's really neat about classes is that, why is that upset? Too few arguments in function call. That's fine. We call the rectangle because one thing that's really neat about these classes, about inherited classes, is that I can actually convert my cube into a rectangle. And because of that, I need to have my rectangle parameters set all the time. I don't want any undefined data, right? So that's why I call the rectangle set width rather than shape2d. Because if I call the shape2d setters, there's a chance that the area and perimeter for the rectangle can go unchanged, and we don't want that. So just in case cube has to get updated and it has to get casted as a rectangle for some reason, we want to have all the attributes updated. I don't want to skip that. So that's why I call rectangle versus shape2d. So here for set depth, we got to do some of the extra hard work, right? Because rectangle doesn't have a set depth, nor does shape3d. However, shape3d does have a implementation for this kind of thing. So I'm going to take that here. This is essentially the body of the code for set depth. But because I made it a pure virtual function, I have to implement what's supposed to be implemented in set depth here. And now I just need to copy paste that there, and then I need to copy paste this here. Right, so that's the benefit of using setters. So because I didn't have a setter here, I had to do everything the hard way of setting this attribute and making sure that it wasn't erroneous. However, here I get to take it, I don't have to take advantage of the setter because I have to define it here. And that's why it's great to define setters. So that way you have the error checking done all in one method. So next we'll start talking about the miscellaneous methods, and we will begin with surface area. So it'll be double cube, that's not how you spell cube, surface area const, right? So surface area, we're just going to return 6 times the get area. And that is because when you count the sides of a cube, there's 6 sides, and so for those 6 faces, we need to get the area of that. Well, that's the area of a normal rectangle, and we have a method that gets that for us. And that's how we're able to kind of use functions from inherited classes to do the heavy lifting for us. So that way I don't have to retype a whole bunch of stuff. Here I can just use the functions that have already been created for me and use them to do the heavy lifting. So for volume, it gets a little bit more computationally intensive because I don't have anything that's kind of related to volume. Well, actually I could. It's going to be get area times get depth, right? Because get area is the product of get length and get width. So volume is just the area times the depth. So we'll have that there, right? So here, I mean, we were able to use stuff from rectangle, which we inherited from, as well as using stuff from shape2d, that kind of thing, which is great. With that being said, these are the miscellaneous methods, and now we will be going with the overloading operators. And we will start by overloading the equals operator. And again, in this video, I'm not going to cover overloading the plus or the multiplication operator. I think by now I've beaten that concept to death, because mostly if I wanted to overload the plus and multiplication operator, it'd be pretty much the same just across all three attributes. Add them, I would add length with length and width with width, as well as depth with depth. And it's going to be the same thing with multiplication, but instead of adding the three attributes with each other, I'll be multiplying the three attributes with each other. So I mean, for me, that's not worth it for me to beat that horse to death more than it already has been beaten, right? However, the overloading the equals operator is very important, because when we use variables, we always use the equal sign. I mean, we could use the other way of creating variables like we do with classes by calling the copy constructor, but most of the time a lot of people like to use the equals operator. I almost forgot this. This is a very important line, right? And this finishes up the equals operator. And again, what I'm doing here, just to review, is that every important attribute I am updating with the getter from this. So I get the length and I set my internal length to this length. I get this width, set the internal width to this. I get the depth from C and I set it equal to my own depth, and the class returns itself. Alright, and that's typically what you want to do. I don't use surface area nor volume because those depend on length, width, and depth, and I only want to change area and surface volume if length, width, or depth change, which is great because in the setters I allow them to only change through those setters, right? Because every time I update length, width, or depth, I call the method updates for updating surface area and volume in all three setters. So that lets me cover my bases in updating these attributes, right? So that when I call it here, I don't need to update surface area and volume because the set depth, well, all the setters actually take care of it for me. Anyways, moving on to the overloading operator. So here, I mean, I just want to print the length, the width, the depth, and the surface area, as well as the volume. So we'll start with the get length, and we'll introduce the space there, and then we'll continue with get width, and I'm actually going to end this statement like that, just like that, so that I can do this and have the get depth, and then we can separate this with the space. Now if I wanted to, I could separate it with a space and a comma, but for this case I don't want to. I just want to have everything space separated. Finally, I print the surface area, and now I need to print the volume. And that should be it. I'm not going to have it space separated because I don't know what's going to come next, and I'm going to let the user format their print statement however they'd like. Right, so this ends overloading the double angle brackets operator, and now we can test our program. So all I have to do is include yet another header file. This will be my cube.h, and we'll create just the two cubes, and I'll say cube C, I don't know, 2, no, let's do 3, 5, and 2. And then I'll have another cube which I'll call, I don't know, D, and I'll have it based off of C, and I'll do D dot set length, and I'll set that to 4. Now we will print C, and then we'll separate it with the space, and then we'll print D and a new line. So let's see what happens when we build. Make sure that the syntax is correct and that everything is correct. If there's any errors, we will take care of it. There's no errors, so that leaves us with just building again and running. So now let's take a look at the response. So we have 352, so that's 15 times 2 is going to be 30, which is good, and that's our volume. And then we have our surface area, 15 times 6 is going to be 90. Then we have 4, 5, 2, 6, 2. Oh, that's interesting. Let's take a look at that error. So it turns out that there's an error with rectangle because I did not overload those operators for set length and set width. So this actually copies the shape 2D one, and because of that, area and perimeter do not get updated automatically. So because of that, I need to use these getters, all 3 getters, right? So because I didn't overload those methods in rectangle, I now have to pay the price by using more code to calculate the surface area and the volume. So with that being said, that should update and fix the error that's here, and that it does. So we have 20 times 2, which is 40, and then we have the area, which is 20, times 6, which is 120. So this is correct. So with that little setback, we fix this and we have created the cube class. So this kind of shows an important lesson in terms of inheritance. So here, because I didn't overload this set area, the set length and the set width, so that way every time I update those, that the area and perimeter get updated, I pay the price. So I know that it's not totally updated. So now I have some homework for myself and for you, and we need to go back and update these setters. And thanks for watching this. The cube shows a class that is created through multiple inheritance, where it inherits both from the rectangle, and the shape 3D class. And in theory, we can keep inheriting from multiple classes. As long as you can build them, you can inherit from them. Thank you for watching, and we'll see you in the next video.